Convergent series. A series is said to be convergent if, as n tends to infinity, the limit of the sum Sn of n terms tends to a definite value. Now consider this example, the series 1 over n squared. The summation of 1 over n squared from n is equals to 1 to infinity. Now if I were to express this series out at n equals to 1, this will be 1 over 1 plus n equals to 2, 1 over 1 square, 1 over 2 square, plus n equals to 3, 1 over 3 square, plus n equals to 4, 1 over 4 square, and it keep on going to infinity. Now, the summation from n equals to 1 to infinity of 1 over n square is equals to 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 to infinity. If we decide to sum up this number, obviously we cannot sum infinity, but if we are summing them up or going close to infinity, are we tending towards a definite value, or is the number getting bigger? To find out, let's experiment this with our calculator. So let's go to the calculator and put that very function in the calculator. So the summation sign, if you want to get the summation sign from your calculator, this is the summation sign. And for you to access this sign, you need to use Shift, then press log. So the summation sign is out, and the function is 1 all over n square. But now we're dealing with x, so you pick x from your calculator. This is x. For you to access x is alpha x then square. So there's a given function from x equals to 1, x equals to 1 to, of course we can put infinity here, but let's experiment it. Let's sum up this function from x equals to 1 to, let me say, 10. So if you're going to add it up from s equals to 1 to 10, the answer will be 1.549. So it implies that, assuming we're going to add it up, 1 plus 1 over 4 plus 1 over 9 plus 1 over 6 to the 10th term, the answer will be 1.549. But what if we extend it to the 100th term? We'll sum it up to the 100th term. So the answer is 1.634. Now, when we add it from 1 to 10, it was 1.5. Now we add it from 1 to 100, it's 1.6, a very small difference. Now let's add it up to 1000. To 1000 is still 1.6. Then let's add it up to 10,000. Still 1.6. So you see, as x is moving towards infinity, this is the 10,000 term, the answer is still 1.6. Now let's add one more 0 to it and see what we'll get. Still 1.6. It's as if the value is getting smaller. The value is tending, the sum is tending to a particular number. So as we are increasing the value of x, the sum is moving to a particular number. The sum is not getting bigger, it's not getting bigger, it's not exploding. Instead, it's converging, it's moving to a number. Hence, the series is convergent. Divergent series. A series is said to be divergent if, as n tends to infinity, the limit of the sum Sn does not tend to a definite value. That is, as n tends to infinity, the sum Sn tends to infinity or minus infinity. An example of series that diverge is n squared. So the summation of n squared from n equals to 0 to infinity, if we were to express it out, when n is 0 squared plus 1 square from at n equals to 1 plus n 2 square, n equals to 2 to 3 to infinity. So if we were to express it out, the summation of n square from n equals to 0 to infinity is equals to 1 plus 4 plus 9 plus 16 to infinity. Now, as n is getting bigger, is this sum tending to infinity or is it tending to a particular value? Now let's find out. Summation sign, we use shift log the summation of n squared, which is x alpha x squared from x is equals to 0 to, now let's start with 10. From 0 to 10, if you sum it up, that is, if you sum this number up from the first term to the 10th term, the answer will be 385. Now, if you sum it up to the 100th term, the answer is 338,550. What if you sum it up to the 1000th term? Now, it's 333,833,500. What if you sum it to the 10,000th term? Now the answer is 333,383,335,000. What if it just move to the 100,000 time? Now the value is bigger. So you observe that as s gets bigger, sum of the series is also getting bigger. The sum of the series is tending towards infinity as it diverges. Unlike the other example we took under convergence, as s is getting bigger, the number here is not getting that big. It's just tending towards a particular value, which is 2. But this very one is moving, it's getting bigger, tending towards infinity. Hence, it is said to be divergent. So, the summation of as n tends to infinity of n squared is equals to infinity. It's getting bigger. Hence, it diverges. Now, if you want to learn more about convergent series or divergent series, you can message me directly on WhatsApp. I will answer your question. Meanwhile, subscribe to this channel, like and share this video. I will see you in my next video. Bye.